Hello, ladies and gentlemen. Now, I just want to warn you about an evil bonus question. Now, normally I don't talk about this, but in class we get out the boom whackers and we play music, and you'll notice there's a difference in sound between open tube and closed tubes. Now, open-ended. Now, this is not. Sorry, I'm going to put one bonus question on the test on this. So, if you want to do this, great. If not, it's just enrichment. Now, open-ended tube. That is a tube that goes like this. Open at both ends. You'll have a wavelength. You will need an antinode at each end. So it's that's a horrible drawing. My apologies. Let me fix that. There. An antinode at each end, so you start with half a wave, and then if you keep on going, let's see if I can draw this, one full wave, and then, sorry, that's one full wave, and then longer tube, you should get 1.5 waves in there. Now, fundamental frequency at the beginning, its lowest would be this one right here. Now, for that, notice length is 1/2 the wavelength. So, what's the wavelength going to be? Well, the length is 3.6 meters. 1/2 the wavelength. The wavelength will be twice that, or 7.2 meters. So there's your wavelength. Oh, sorry, that's what I apologize, getting ahead of myself. So we're asked to find the wavelength, 7.2 meters. And then we go on, what's the frequency? So here, the frequency, this is velocity. We have wavelength, solve for frequency. Velocity is frequency times wavelength. And I feel like solving for frequency, so divide both sides by wavelength offhand, because I can. .346 meters a second. As I said, this open tube stuff is enrichment, but I always get the question, why do the boom whackers sound different? Because the tube is open versus closed. Anyway, the frequency here is 48 hertz. Quite a low frequency. All right, and I'm going to stop there. As I said, this is bonus. If you got it, great. If you're interested, great. If not, well, that's too bad.